glass box testing. Most of you may know the typical black box, white box, or gray box testing, which is easy to distinguish because black box obviously is the same like when you use it in other ways of saying it, that you have no idea, you just touch the surface and see what you can do. So same for an attacker. They usually don't have any information, they have no credentials, and they're just attacking a website or a system and treating it as a black box. Whereas in contrast to that, of course, white box, which is obviously the opposite color to this, is where there is transparency given. So most of the time, not only one set of credentials is given, but multiple, like elevated rights and also simple rights, because you would like to test the privilege rights escalation, and basically gets also some guidance on terms of how the application is structured, maybe a system diagram or something that helps the tester to navigate. This is usually white box that you can go in. Gray box is something in between, so maybe not enough sufficient credentials, so the attacker has to be, or the tester has to be a bit more creative how to get in and how to navigate within the system. Not all information is fully transparent, but with a bit of energy, this tester can find its way and explore the entire application. So therefore, what does glass box testing mean? Sometimes when you look it up on the internet, it is kind of put together with white box or clear box testing. Whereas I would like to emphasize that glass box testing is definitely the most transparent way of testing. So aside from having a set of credentials, the full system design, even applications that are associated with the system are fully laid open to the tester, including the full source code review. And this is probably the most important thing, that the source code review of that deployed version is delivered together with the access to the system, so that the tester really can find and doesn't rely so much on the graphical user interface and the visible items. He can rely on the source code to see which modules should go, can definitely run a code review in parallel, see what pops up and what is critical, navigate to that relevant screen, and try to exploit and even build some more attacks around that. That is the whole idea of Glassbox. Fully transparent, it's more clear than white box, and therefore everything is laid open. In some contexts, it's also called structural testing, which again it gives the hint that it's that you have full visibility for navigation through a complex system. So as I said, architecture, design, code, and the setup is totally described and documented and given to the tester. So therefore, the time box that is assigned to do a full testing here, be it penetration tests, code review in combination, allows going beyond the OWASP top 10. And then again, don't forget the OWASP website offers more than 700 attack patterns. So top 10 is only the selection of the selection, and it's the aggregated view on all these things, so that at least there's a defined scope of work, but no one is limited to this. And especially when you have the glassbox testing approach where everything is surrendered to you for testing as an evidence and documentation, you can actually go more than top 10. And you should, yeah, and especially not hesitate of DDoS attacks, which is also sometimes excluded from normal pen test because the tester doesn't want to cause any disruption, even in a test environment. So what else can then the penetration test discover when looking into the Glassbox setup? Obviously, there are business logic issues that can be discovered. This is something that is not even in the OWASP top 10. Because it depends on the application's purpose, it depends on the business processes that are covered with this, also depends on the users and the logic they use as a segregation of duties. And that is the business logic part that can be tested. And access control issues where, again, elevating rights, that's one thing, or escalating rights. But on the other side, also finding any backdoors, any bypass, any additional authentication ways that are maybe weaker than the standard one, or have been forgotten to be removed because maybe sometimes there was an upgrade going on for the access controls and it was just made invisible. But due to the glassbox testing approach, where you can see the code, where you can see the design, you may also go into abundant functions that you can then exploit and then still get into the system or onto the infrastructure. And that is the whole idea behind it. So I'm a fan of it. Of course, it's effort. You have to put that stuff together. It has to be also concise. It shouldn't be misleading because then it defeats the purpose. And of course, it also appeals on the skill set level of the tester, because some of them, penetration testers, they just know how to do penetration tests for a certain technology. And if you come up with creative ways how to test things, it may end up a bit in a disaster because it's an unstructured way. Even though it's a structured testing, but it's unstructured in terms of it doesn't follow the standard procedure which is provided by the industry. So hence, navigating through complexity of the system, of course, it also requires that the system has a certain complexity. If it's a simple one, I would not always recommend to prepare all these things. But important is also to document the whole testing path. That is even more important when you want to conduct retest later and maybe the tester is changed as a different person doing it. So ideally this whole path, because again, too much information sometimes gives too much choices, and these choices have to be done wisely if you want to navigate within your time box. And therefore, it's important to document the test path, to say, how did I get in? What did I get out? What else did I try? So that when you want to conduct retests and you want to replicate a certain finding and see if it has been fixed, you can first run through this as a regression, and then you can still navigate test cases around that initial test path to see if maybe the fixing of the issue has caused another issue to appear, which may result in slightly lower vulnerability, but still kind of the vulnerability persists. And especially with the knowledge of the previous testing, the tester could make a new case out of it. And set focus areas based on design or business impact. That is also, I mean, it should not be only based on business and design, but as I say, if the system has a certain complexity, it makes sense to start with the critical functions first, because obviously, I mean, it's up to you how to organize it, but recommendation is also when you have critical functions, critical findings, fix them first and then retest. Don't collect the whole bucket of findings and then you end up with 20 findings that you have to fix. It will take too long. There will be no incremental progress. You may retest one or two, but then you still don't have the impact. And my suggestion is always still to run a full regression every time something has been changed. Even when something has been fixed incrementally, run a full regression, because there is always side effects. There's no thing that you can go to the piece of code or go to the configuration and just do certain mitigation efforts and then nothing will be affected than this area that you're touching. This is just not happening because the systems are interconnected. There's a lot of complexity in it, and therefore maybe incremental testing and incremental retesting and incremental fixing is the better approach, because then you can shave off highest criticality first, work your way down, reprioritize. Maybe some functions you can't fix. Maybe you have to see if you're going to disable them and you're not using them anymore. But that's why it's good when you have the architecture and the design overview and the setup overview, because then you can make such decisions. Which function can be separated? Maybe I can move this piece into a different module and I can create a separate setup for that and have a different kind of countermeasure protection for this. That's why, again, glassbox test, very good. Not every tester can handle. Not everyone has always the material ready. But definitely for your most critical applications, you should pursue that path and get everything prepared.